This is going to discuss arrays, which are a way of storing multiple values in a single variable. So here we have a single array, which we represent as a bunch of numbers, one after another, and down below we have indices, which are going to be used to refer to which of those numbers we're actually interested in. The numbers for the indices go from 0 up to the number of values that we have. So we always start our indices at 0. Now we can declare arrays like this. We specify the type of the array, followed by the name of the array, followed by the number of values it can contain in square brackets. So this is saying I'm creating an integer array of 5 members called AR1. Here, we're declaring a character array of 10 members called STR. Here's a double array called D1. We don't specify the size, but we assign some values to it, which initializes it. And because we initialize it with 4 values, it automatically sets the size to be 4. Here we have an array of 3 integers, which we assign 1, 2, 3. Here we have an array of 3 integers, which we assign 1 and 4. But because we didn't provide enough values, it automatically adds an extra 0 for us. So whenever we don't provide enough values, it pads the rest with zeros. If we provide too many values, it just stops using after it hits the number of values it needs. In the next one, we create an array of size 3, and we initialize it to 0, and it's going to pad it with more zeros, which is equivalent to setting the entire array to be 0. Arrays are stored contiguously in memory, which means one after another. So here we have an array of 8 grades. Every one of them is an int, so we take 4 bytes, 4 bytes, 4 bytes, and the subscripts for them are 0, 1, 2, 3, and every one of those subscripts refers to a 4-byte integer. Now, we can use the subscripts in square brackets to access which member of the array we want. So here I declare an array of 5 integers called A, and I initialize it to be the numbers 1, 2, 3, 4, 5. I declare I to be an int. I set A sub 2 to be 9. So this is what a subscript looks like. It's a number in square brackets, and it's going to refer to 0, 1, 2. That 3 is going to get replaced by a 9 because it's in subscript position 2. Remember, the subscripts go from 0, 1, and 2, so that's how we get that. Then I'm going to do a for loop, and I'm going to say for I equals 0, I is less than 5, I plus plus. I'm going to printf %d, a comma, and a space, and then the value of A sub I. Well, because that's in a for loop, I is going to go 0, then 1, then 2, then 3, then 4, and then it's going to stop. Now, if you look over here, it shows what it prints, and it prints out the 1, the 2, the 9 that we overwrote, the 4, and the 5. So that 9 is there because that's what we did with this assignment here. Parallel arrays are another way that we can store a lot of related information in multiple arrays. So here I've declared 3 arrays. This is an array of 5 integers. In stock is an array of another 5 integers representing how many items we have in stock, and price is an array of doubles representing the price of each item. So SKU is a stock keeping unit, and it's that number that many stores use to represent every unique product in the store. So what this says is SKU number 122, we have 5 in stock, and its cost is $59.99. Item 349, we have 2 in stock, and it costs $7.49. So every column represents related information. One of the nice things about parallel arrays is the arrays do not all have to be the same type. So here we have an array of doubles, but the other two are arrays of ints. SKU and in-stock are ints, but price is double. And that's okay because they're all stored as separate arrays. So parallel arrays allow us to store related information on some kind of a product or whatever in a way such that we can have different array types storing different types of information about the same product. Now, character strings are simply arrays of more than one character. The way they decided to represent a character string in C was to put a string terminator, which we represent as \0, on the end of a string. And that marks the end. The other way, well, they could say we have a different array for every size string, but string, the values of names and things are all different sizes, but when we declare arrays, we can't have a different sized array for every name. So what we do is we make arrays bigger than we need, and then we write a string in there with a \0 when that string ends. And that string might not use the entire size of the array, but that's okay. So the full size of the array does not always need to be used, but our array has to be at least one larger than the string in order to allow for the string terminator. So down here we've got a character array called name, and here's its indices here, and it's going from 0 up to 17. And there's the values. My name is Arnold, followed by the string terminator, which is your \0. Note that the spaces are in there because a space is a real character. A lot of people think, oh, it's nothing, you can't see it, it's not really there. But as far as we're concerned, a space is a real character. So that's how you would store a string in an array. Now this string occupies the entire array. Not all strings will occupy the entire array. So here's some examples of other strings. Here I've put the indices up top, and this is a 10-membered array, and I wrote dog in there, D-O-G, followed by a string terminator. Now I made it an empty string by simply putting a string terminator in the first position. So by putting a string terminator in the first position, it creates an empty string. OG and the string terminator are still there, but because all the processing algorithms say as soon as you hit a string terminator, that's the end of a string, if I put it in the very first position, it never looks any further to see if there's anything left in the string. So as soon as you see a string terminator, that's your end of your string. You don't look any further. So this particular string is called an empty string because there are no characters in it. But it is a string because it's got a string terminator. Now this is a little bit about how we can initialize a string. So if I say car name without a size is initialized to Fred, it creates an array of 5 characters. It assigns Fred plus the string terminator. And in fact, anytime we put something inside double quotes, that creates a string which automatically has a string terminator on it. So that's a little introduction to the concept of arrays.